Okay, so this is ugly new interface on Facebook. You know, it doesn't look like it's actually streaming. Oh, this is all weird colored. Let's restart this. That's fine. Let's put this in the other window. Oh no, that's not what I meant to do. Let's put this in the other window. There you go. That's much better. Okay. I don't see my live video here. But I assume it's, well, let's see. Let's just, as long as it's streaming on Twitch, I could get going. Twitch. Open two links for some reason. Okay, yeah, it's here. I'm gonna open this in other windows so I can look at my stream settings. Okay, bear with me for a second while I get this all set up. It's my first time streaming on this account on this computer, so I didn't quite have everything set up yet. So I have two Restream accounts, one for business, which is this one, and then the other for music. And that one I do my band stuff or whatever. I thought this was actually going to be streaming to my... Okay, it is streaming to Facebook. According to this, it is. Okay, whatever. I'll just assume it's all working right. Okay, so I'm just going to do this for a half an hour or so, but maybe I'll go till like a little bit after 9 because I start a little late. So let me just give y'all a rundown of what I've been doing open source wise. So I use all of my, or most of my GitHub, most of my repos are in GitLab, and I just have them mirrored on GitHub. So starting August 18th, I've been pretty much contributing to open source every day, and I kind of started more heavily more recently. Before that, I was just kind of working, mostly full time for a client, and I didn't really have much free time. I still don't have free time, but whatever. I'm still doing a lot of open source stuff right now. So let's look at the stuff that I've been working on. GitLab, Hacks Grig. So do y'all hear me fine? This is like my good mic, and I think I have the gain up pretty high. Let's see. Okay, I don't see anyone commenting on the stream yet, so I assume that you're all fine. So I've been trying to improve the audio support in Hacks because I think Hacks has a lot of potential for being a good language to make not only audio stuff, but also just a good language to implement general libs that you then transpile to make libs for other languages instead of having to people having to port things constantly. It seems like this might be a good way to at least reduce the amount of porting that happens. There are some holes in that, Hacks makes perfectly fine C++ for compiling and running, but it's not really good for integration into a C++ application. I am working on something that will, at least for audio contexts, help around that, but I'm not working that today. What I've been working on the past couple of days, aside from working for a client and some other things, is open source wise, the past couple of days, the thing I was working on is this, which is my HAX based implementation of open sound control. I thought that OSC was like a lot more extensive than it really was, and I just kind of put this off thinking that, oh, this is like a really complicated thing. It's not like MIDI, it's complicated. But then I looked into it and I pretty quickly got a server working, and with all of the main data types and everything. So the main thing is here I use, GitHub Flavor Markdown allows you to make tables, and it works on GitLab too. And I just made a chart of everything that's supported, which so far isn't that much, but a lot of these are gonna always be empty because it's just not possible. But if you're not familiar with it, open sound control is like supposed to be a more modern replacement for MIDI, and it's a lot more flexible. You can send to arbitrary endpoints, and you can send arbitrary data types, and it's supposed to be transport independent. So you can send it over UDP or a TCP socket, and then now people are using like WebSocket as well. But I think UDP is like kind of traditionally the most common. A lot of things are just work over UDP, so I'm mostly focusing on getting UDP working on as many platforms as possible, and as many targets as possible, or targets and platforms like Node.js and HTML.js. Those are both a JS target, but different environments. Some of these targets I don't really care about, but I think some of the value in implementing something in HAX is you can serve something that's not as, not, that doesn't have as much excitement generated for it. So, PHP is still pretty widely used, but people aren't like excited about implementing some audio thing in PHP, but who knows, there could be some value in having open sound control server that works on PHP. So for any of these platforms, if all I have to do to implement it is just like add a line to my continuous integration config so that I at least know that my tests are running, then I'll go ahead and do it. I don't think Swift is going to work with UDP though, and that is definitely a dying platform. I don't really care about Neko, but I think just automatically that supports whatever CPP works, just the way those two targets work. These are the targets I usually care about: CPP, Python, Node.js, HTML.js, and then like the new hash link. I think Java and C# are also important. So let's get into what I have going here. So I was working on, this is like the Docker file, the Docker config for my tests that GitLab runs. But I'm gonna open rig dot, this is not, oh, here we go. Why is it slow? At the end of the day, Visual Studio Code is an Electron app, and it's just running a browser and JavaScript. So sometimes it's not that snappy. Okay. So I don't need the welcome screen. Not updating right now. Yeah, that is not fast. Sometimes just the process of streaming slows down everything else on my computer, even if I'm on a fast computer. Although this computer is not terribly new. Lix extension. Okay, whatever. So I have pretty extensive test coverage for this. In fact, let's look here again. You see I've got pipeline, that's the GitLab Python pipeline, and then here's the Travis. And they both basically are running the same tests, but slightly different environments. I guess it's good to have some redundancy, but let's look at what that looks like. while I'm waiting for that to load, let's go back here. And so my test is, so right now I just have the server implemented, the UDP based server, and that requires threading and UDP to be supported. So basically it's not going to, as it is, it's not going to work on all HAX targets anyway, but some might have one and not the other. Like some might have UDP but not threading, or vice versa. So I'm going to try to make it flexible where you can pass in whichever type of server you have, whichever type of socket you have. Might even support like OpenFL socket, which would add support for web sockets, like right out of the box. And then also work in a threaded environment or just like a blocking environment. But right now it's threaded. Like I have like kind of 3 different threads going on. There's like the main thread, the thread that reads from the UDP socket, and then the thread that interprets what is read. The reason I have 2 is because I don't want, if another UDP packet is sent while I'm processing it, I don't want to miss it. UDP is not as forgiving of like missing packets like TCP is. You have to like kind of read it as it's coming in. So it's good to have a separate thread reading UDP sockets and not like doing something complicated like interpreting it and calling a callback in the same thread that you're reading it. But I can make the code do that if in a context that doesn't have threading. And sometimes it's just a matter of, you know, the language or the environment has support for it, just the HAX compiler doesn't provide externs for it. Like Python does, at least in theory, have threading. Some performance limitations, but it does have threads, but it doesn't appear that I can do threading. I can just use like the HAX standard thread in the Python target. So anyway, here's how that test works. So I have, this is like the expected messages. So the first message just kind of has one of each like data type to test it. This is not like realistically how any OSC message would actually look. Usually they're like 1, maybe 2 pieces of data on them. Like so often OSC is just like a single floating point. But this is just like a test to make sure all of them are working. And I'm testing it against like a string representation of what it would look like. One thing that's cool about OSC is you can transport MIDI over it. It has like semantics for that. So I'm going to hook that up later. I'm going to make it where you can use grig.midi. If you use it with grig.osc, then you can get like you can hook up your MIDI callback to an OSC receiver or whatever, to a server. And then the main test right here, it listens on a port. Oh, you know, let me pull. This is not the latest code. I was just working on it on my Mac, so. Okay, perfect. Yeah, this file got changed. Got changed quite a bit. Okay. So this is the main one. So now I have ports a variable, and the reason is because I actually spawn a separate application that sends it, and this application uses a different library. This uses already existing JavaScript OSC, so I'm using someone else's implementation to test my implementation. That's kind of funny, but like it seems like a more robust test than testing it using my implementation, because like if I'm consistently wrong about something, then my test will pass and it won't mean anything that it's passing. So yeah, it sets up a UDP listener, listens on port 8000, starts the server, and then I register this, or no, it instantiates the server, then I register this callback, and this callback can do some asserts, and then I start the server, and then as a separate process, I start the test client that uses that third-party OSC JavaScript library. And then I close the server, and then I check that all the asserts are valid. And then that nets me out. So you can see most of the recent ones have passed. Not actually getting to coding yet, but maybe I'll do this every Thursday, and the next time I'll get to coding. Yeah, my computer is like a lot more sluggish when I'm running OBS, the application I use to stream. Something about that just does not agree with everything else in the system. Okay, so you can see it. This is very complicated, but on here you don't see the color output. I do see the color output on Travis. I like this is color, but this should also be green. If you run it locally, this will all be green. But you could see right here, like it tests that you can register and then deregister callbacks. This shows that I can. Oh, and then OSC, like the semantics, expects you to be able to have filters on it. So I put a filter such that when I run this kind of same test as here, I only get 2 messages because I'm only looking at messages that start with carrier, and then I use like a regex for that, and then have like a single floating point associated with it. So I got exactly 2 messages, and then here this is like the more thorough test that goes through this data structure I made that represents everything that I expect to see in the messages sent by that test client. And then the test client looks like this. So I think the next thing I'm going to do is make a test server using that same lib, and then make my client. The client's actually easier. Client, I don't have to deal with like servers and stuff. UDP, you just fire off the packet. And then as far as like, if you expect responses, then what you would do is you would have a server and a client. So the client doesn't have to deal with listening. So potentially the client could actually be supported on more platforms if somehow it has UDP support but not threading. But again, I do need to make a non-threaded version of the server. So maybe we'll just start working on that. Let's start, and a lot of that's just going to consist of sending off, firing off UDP, and then kind of doing that reverse of what I'm doing in server, where I decode the, let's look in here. So in server, I could have made it a separate, yet another separate class, but basically right here is where I'm decoding. So I'm getting like the raw bytes from the UDP or whatever port. This is kind of agnostic about what, as long as it's a bytes input. Like really when this interprets a packet, it's a full packet. So OSC, you don't stream within a packet. You basically, you get like a whole packet, and that packet either represents a single OSC message, or it can represent a bundle, which is like multiple messages at once. So basically, a message is going to be a bytes instance, and then I make it a bytes input based on that, because Hax's input interface, that has more stuff in it to like read different data types, more than like the bytes interface by itself. And it's just kind of a little bit easier to use. For the most part, I don't need to keep track of my exact location in the stream. But since it's a bytes input, I actually do have that information as well, unlike a generic input. So you could see like these are the different different argument types. Actually, the 4 that all OSC implementations are expected to implement are these 4: float 32, int32, string, and blob. But then there are these other ones that are common, so I implemented those as well. So you can even send a symbol, which is basically a string by another name, a single char, um, an NTP time code. Uh, a lot of these aren't that useful to me, honestly. I think in most applications, float is probably what you want, or maybe int to represent kind of Boolean values. Although I noticed that when I was playing around with different uh, apps from the App Store that do OSC, it seems like they just send floats. It seems like float is like the common thing to send. um, and that would have made things easier if OSC was just float, but then it would have made it less flexible too. Um, to me, the most interesting thing other than float is MIDI, because then you can use OSC as a way to like transport MIDI over like a internet connection or something. So anyway, I got those all implemented. So my client just needs to kind of do this all in reverse. It needs to generate the raw bytes representing these different data types. So let's start by making a client. Oh, and actually, let's look at the constructor for server, because I'm gonna. Oh, actually, the constructor doesn't do anything. So usually, I do not want. Generally, I don't want constructors to potentially fail. Hex can handle that better than C++, but you still don't want. I think like a new is something that you don't want to be something that can fail. If something could fail, I prefer to have it have like a return a promise, and then on that promise you can register like a listener on failure and another one on success. I think that's the way I prefer to make interfaces. Or at the very least, if something's gonna like do something more old-fashioned, like return an error code or throw an exception, I'd still rather do that in like in this case, in the connect function. Where there's a start and then there's also a connect. And I'm not going to use threading in this at all. I'm just going to, like, I can make it threaded later, so that oh, yeah, okay, the first step, I'm going to make this work without threads, and then later I'll add threading so that sending the message is asynchronous and then immediately returns. But for now, we'll make it, for the first try, we're going to make it blocking. How about? So maybe I'll make another class called packet sender. Maybe. Does that work? Does that make sense? Maybe that doesn't make sense. I don't need to do that. I just need to have like maybe pass a socket in or some abstract. Maybe I do need that. Okay, let's make an abstract packet sender class, and then that can handle that in turn will connect to like a socket or something. Okay. Packet sender. And I'm prone to like radically restructuring my code repeatedly. You know, like I'll be working on this thing and being like, you know what, I don't like how this is, and I'll just redo like half of the things. So there's a good chance I'm gonna like radically redo how the server is structured to make it work in blocking and non-blocking modes. Sender. Okay, so and then actually, like, packet receiver is like abstract, right? I mean, it's interface. Let's do that here. Okay, so want to get the semantics parallel. Okay, send packet. And I do have a separate packet class, but in this context, packet just refers to bytes instance. And we don't want this to return anything, probably. Maybe later I can make this return a promise, but for now we'll just make it where you're in the dark as to whether it even succeeded or not. So the first step will be a simpler interface, and then I'll make it better. Okay, and then So then we'll make a AP, or we're doing that way, packet. Okay. Plus UDP packet sender implements packet send. Okay, so hopefully if I save this, it'll complain. No, it ain't complaining. It should complain about the lack of, okay, yeah, now it complains. Okay. Field send packet needed. Cool. Okay. Public. And actually, I'll probably want to just include that in this file. Okay, so now we got that imported. What is this complaining about? Unused. That is most certainly not unused. Okay, because my computer is sluggish right now, the IntelliSense or whatever this is slow to pick up on things. Okay, cool. Okay, now it's all good. Okay, so so this one I'm gonna need maybe pass in a socket, a UDP socket. Actually, maybe can I? UDP socket and hex actually derives from, even though it totally does a different thing, it's actually derived from their TCP socket class. So maybe I can actually make this a generic socket, at least for now, because it probably does the same thing whether it's UDP or TCP. Either way, it's just going to do a send, I believe anyway. First, let's look at UDP socket to see if there's anything different about its interface I need to keep in mind. Okay, read from to broadcast address. So this has a send to. Do I want to be able to do that? Let's see. I probably do need to use that send to. How does this do? So this, it gives me a so the way the socket class works is I actually would call open, or I would call, not bind, that's for a server, I would do connect. But that's not really how UDP works. You don't do like a, I don't think I even need a call. Okay, yeah, so it does make sense for us to be a separate thing. Okay. In fact, I don't even think I need to pass in a socket. I could just make one. I don't even have to do it in the constructor, because the way hex works, you can actually instantiate here, and then it's like implied that it happens in the constructor. So sys.net import sys.net.udp socket, and then socket equals new. So now the only downside is I'm not sure. How should this? Okay, I think I'm just trying to think so I can keep the same interface, whether it's whether we're dealing with a, or it doesn't have to have the same interface though, except send packet needs to always be the same. So I need to specify the address elsewhere. I guess, yeah, I guess the way it should work is if you want to send to multiple different addresses, you probably want to construct multiple of these. And then the default assumption is you are, yeah, so maybe that's what I'll do. I'll have it where you pass in an address. How do I construct an address? Let's see. sys.nest.address. Oh, this is only used by UDP socket. Oh yeah, okay. Oh, so, okay, the way this works is I construct it and then I set the host import. Okay, so yeah, I don't want to actually make people use this class because it's not fun to use. Import. It's like a very C-like thing. If you have to like set the value of fields on an object and then pass that in to make something, that's kind of weird. Okay. Private var address equals. And then, okay, so I'll make the new host import. So in this case, you don't need to have a separate connect method because this doesn't do anything that could fail. And it's okay for the, you know, this and the TCP can have a different interface as long as they both have the same send packet. That's what all that matters. So this can have like a host. That's just, oh wait, no. Host, oh no, these are just ints. Okay. Wait, does that make sense? How do I specify a host as an int? That doesn't make sense. Does that int represent a IP address? That's kind of weird. Can an int represent an IP6 address?